Resolution of a vector. So this is breaking a resultant up into components. It's easy to do with the x and y component method, right? Because if you have orthogonal axes, you can just break it up into x and y. So if we want to break the this vector here into components that act along the v-axis and the u-axis, we can do it graphically, and you just kind of think about it as that triangle rule in reverse. Okay, so here's our vector with our u and our v axes, and I draw my f sub v along that axis because I got to get from the tail of my resultant. Remember that if you add vectors together, the tail of your first vector starts at the beginning. You move the other vector to the head end of the first vector, if you have a second vector, and then when you put its tail there, you put its head where it belongs, and then your resultant's going to start at the tail of the first vector and end at the head of the last vector. And we're just running that in reverse, okay? So I had to draw a vector along V here, and this is a component. So you can see that this vector, I drew it as long as I did because I kind of saw that I have to draw a vector along U, which is going to be parallel to this U. It's going to have to come back here, and it's going to have its tail up here and its head down there, so that my first component starts at the tail of the vector. So the tails match, head at the other end, tail of my next vector, and head down here. Okay, so this is what the final answer would look like, because this is just this triangle rule in effect. This f sub u vector is really not all the way over here. It's actually acting over there. This was just a graphical solution. So this is what the two components would look like. FV would be pointing up like this, and f sub u would have to be pointing down like that.